Hello friends, now let us see the questions from BJT, from the remaining topics of BJT which appeared in GATE exam. So the topic in here is configurations of BJT. So let us see questions from configurations of BJT. If a transistor in the figure shown here is in saturation, then you have to find the relationship. And for a transistor to operate in saturation, the minimum IB should be equal to IC by beta. So IC is always equal to no, IC is always equal to no, IC is greater than or equal to no, IC is less than or equal to this. This D is your answer. Minimum current, base current to drive the BJT in saturation is IC by beta. So you simply IC, this is minimum. So IB should be greater than or equal to IB minimum. So IB minimum IC by beta. So IC should be less than or equal to beta into IB. That was the question from this topic. Then let us see the next question. Which of the following statements are correct? For basic transistor amplifier configuration, CB, that is common base amplifier, has low input impedance and low current gain. CC amplifier has low output impedance and low current gain. Common emitter amplifier has very poor voltage gain and very high input impedance. The current gain of common base amplifier is higher than the current gain of common collector configuration. So let us have a look. Please see, just remember this table. This table is very important. For I have given you that table in my video, that is on configuration. I discussed this table in common collector configuration. So if you want to handle all these questions, there are plenty of questions from this table, especially in engineering services prelims exam. So remember, you should mug up each and every point. Note these numerical values. You don't need to remember the numerical values, rather these comparative relationship for handling the questions. And there were questions in GATE as well. I am discussing this, but plenty of questions appear from this in engineering services prelims, those who are preparing for engineering services also. So answer here is A. What was the option A? Common base configuration has low input impedance and low current gain. So let us see the common base configuration. Input impedance is low, current gain is low. So this table will give you all the answers from the configurations. Now choose the correct match for input resistance of various input resistance of what? Various amplifier configurations. Common base has low input impedance, common collector has very high input impedance, common emitter has moderate. So you have to match. So this is what I matched. Common base has low, common collector has a very high, this, and common emitter has more this. So let us see the answer. This table I am giving you to mug up in every solution, right? So answer is B. Common base has low, I told, common collector has high, and common emitter has moderate. That's it. Let us see the next question. If a silicon NPN transistor, the base to emitter voltage VB is 0.7 and collector to base voltage is 0.2, then transistor is operating in normal active mode. Why? Because if both junctions are forward bias, then it should have been 0.7. So it is not in 0.7. So it must be in cutoff, it is in active. So this is saturation, that is normal active. So I am giving you the cut-in voltage. So here VB is more than cut-in voltage, so it is forward bias. VCB is less than cut-in voltage, it is reverse bias, so that is normal active mode of operation. So let us see the next question. Common collector transistor configuration has following. Common collector, you know, that has high input impedance and low output impedance, so that is your answer. That table you need to remember. I am not giving that here again. Now let us see the questions on Ebers-moll model. Ebers-moll model is applicable for what? Bipolar junction transistor. Very simple question. The Ebers-moll model of BJT is valid for what? For all the modes of operation. I have already discussed that in my video. For active, saturation, cutoff, all mode of operation, including inverse mode, that is not given here, including inverse mode of operation. Fine. Now let us see the questions on non-ideal effects of BJT. The breakdown voltage of transistor with its base open is VCEO and that emitter open is what? That is BCBO. So which is more? BCBO is more. I have discussed that in my video, but still you should remember this relationship, and from here you get this is more. Why? Because HFE is about 100, so it will be about, when you take it out of root, it will be approximately 10, so this is almost 1/10 of this voltage. In common emitter BJT amplifier, the maximum usable supply voltage is limited by, maximum usable supply frequency is always limited by what? Avalanche breakdown of base emitter? No. Collector base breakdown, collector base breakdown voltage, collector emitter breakdown voltage with base open, collector base breakdown voltage with emitter open. So here please, there is a correction here, it should be, here it is not given, you can see this is open emitter VCBO. When emitter is open is VCBO, when base is open it is VCEO. When base related between open base breakdown voltage. So let us come here, open collector emitter function with base open, so it should be VEO. When base is open, you can see here, when base is open, it is BVCEO, and when emitter is open, it is VCBO. So when base is open, it has to be collector base breakdown voltage with emitter open, collector emitter breakdown voltage with base open. So we know the maximum voltage is what? BCVEO. This is BVCEO is less than this. We have already seen here. So this is the maximum breakdown voltage. Fine. So this limits the voltage B, that is BVCBO. The next, the early effect in BJT is caused by, what is the reason? That is large collector base reverse bias. When there is large reverse bias at the collector, so base width will reduce, and that causes the early effect. We have already discussed at length in my videos. The phenomenon known as early effect in a BJT transistor to a reduction of effective base width is caused by what? That is caused by that is reverse biasing voltage at base collector junction. So we have just discussed it. Fine. Then an increase in base recombination of BJT will increase base recombination will result in increase in what? Breakdown voltage. How it comes? Let us see that. When there is increased recombination, IB will decrease, beta will increase, and when beta increases, this will decrease. So it will reduce the, let us see it again. An increase in base recombination of BJT will increase when there is base recombination taking place. So what will happen? Alpha will, in this case, alpha will decrease and beta will decrease. Both are going to I'm sorry, I need to see the concept again. Here, an increase in base recombination, you are increasing the base current basically. When collector current will decrease, so ratio of IC upon IB will decrease, beta will decrease, and when beta decreases, that means HFE is decreasing. When HFE is decreasing, this will increase, so it will result in increase in B. This is what I am trying to say. So that is the explanation. Next question, if base width in BJT transistor is doubled, current gain will increase? No. Unity gain frequency, we have not discussed. Early voltage will increase. Why? Because when you increase the base width, in that case, if base width of bipolar junction is doubled, so increase in base width will result into increase in base current, but definitely width of the base will increase, so more voltage will be required for the early effect. So answer will be D simply, because when you increase the base width, that means more voltage will be required for covering the base region by depletion layer. That's it. So that explanation is given to you, and no question have appeared from switching transistor in gate till date. So these are the questions from remaining topics of BJT. Thank you for watching the video.